Okay, now we're going to start with question number 13. We'll do 13, 14, 15, and 16 in this video. So, number 13 says a fraction model is shown. What fraction represents the shaded area of the fraction model? And then we have to explain how we found our answer. So first of all, the most common, I guess, wrong answer that I usually see is third graders will put 1, 2, 3, 4, 5, 6, 7, 8, 9. They'll say 9 over 10, 11, 12. They'll say 9/12 is the fraction. And that is not correct, because that would tell us that 12 pieces equal one whole thing. And that's not true. In this case, we have 6 pieces that equals one whole thing. So if this was a candy bar, we actually have 2 separate candy bars here. So when we're talking about the fraction, there's 2 ways that you can write this. You can write this as an improper fraction or as a mixed fraction. So if I wanted to write it as an improper fraction, I would say that there are 9 shaded, actually out of 6 altogether, because it only takes 6 pieces to equal a whole thing. This is called an improper fraction because the number on the top, what's that called? What is that number called? Is that the numerator or the denominator? That is the numerator. The numerator is bigger than the denominator, so that is called an improper fraction. The other way that I could write this as a mixed number is like this. I would say I have one whole thing shaded in, which would represent this one. And then I would say I have 3 out of 6 of the other one shaded in. So I would say 1 and 3/6. If you wanted to get really technical, you could even say that this has half of it shaded in. So even if you put 1 and a half, that would still be correct. So there are multiple correct answers that you could have put there, but one answer that you could not put is 9/12. So when you explain how you found your answer, your explanation is going to have to match which one of these you went with. So you can say something like there are 9 pieces shaded in and it takes 6 pieces to equal a whole shape. You can say I know because one whole figure is shaded in and half of the other one. Okay, so it kind of just depends on what you did. So you just make sure that your answer here matches your answer up top there. Number 14 says enter the unknown value in each equation. So we need to figure out 6 times what equals 42. Well, if we skip count by 6's, we have 6, 12, 18, 24, 30, 36, 42. So there's 5, 6, 7 times that we counted by 6's. Something divided by 4 equals 9. So to figure out what that big number is, I'm actually going to go opposite, and I'm going to say 4 times 9 would equal 36, which means 36 divided by 4 equals 9. I used a fact family there to help me. This one, 15 equals, be careful, they tried to trick you there. 15 equals something times 3. Well, 5 times 3 equals 15. We have 3, 6, 9, 12, 15. I had to count by 3 5 times to get to 15. And the last one, 14 divided by something equals 7. 14 divided by 2 equals 7. Okay, so that was number 14 there. And now we'll do 15 and 16. 15 is a little bit tricky because they tried to give us something on a piece of paper that we normally would do on a computer. It says draw and label both points on the number line to correctly plot 1/3. Now the trick here is that it depends on where you put the whole number 1. So there are actually 2 correct answers for this, okay? The first thing that you could do is you could say this is 1/3, 2/3, 3/3. And 3/3 would be the same as 1, so you would plot the big number 1 right here, which means you would plot 1/3 right here. Okay, so you would put those 2 dots there. The other thing that you could have done is you could have said, this is 1/3, this is 2/3, this is 3/3. See how I skipped one in between there? So we would have put the big number 1 there, and then we would have put 1/3 right there. Okay, the trick is that you cannot put the big number 1 at the end here and get anything in between here to evenly equal 1/3. That's how they tried to trick you there. Okay, so you either could have hopped each little tick mark as 1/3, 2/3, 3/3, 1 and 1/3, 1 and 2/3, 1 and 3/3, which is the same as 2, or you could have skipped a line in between. Okay, and the last one for today is number 16. A rectangle is shown. and it shows us that each of these is equal to 1 square meter. What is the area in square meters of the rectangle? Now I know we didn't actually get to our area and perimeter lesson before we unfortunately had to take this unexpected break. But we have talked about area before. So area is the amount of space that something takes up, like an area rug takes up a certain area of your floor. So when we're finding the area, we're counting up the space inside. So what is the area? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 square meters. It's as simple as that. You just have to count them. Okay? Remember, if you have any questions, you can call me, text me, send me a message, whatever works for you. Thanks, guys. Bye.